So the first question is, we've been asked to find the perimeter and area of this shape. So this shape we know is a rectangle. So don't be put off by seeing 6 x's. What they mean by x is x could take any value. So you can have x equal 1 or x equal 2. So any value for x, you'll be okay. Hold on. Give me 1 second, please. Sorry, is that stop sharing?
Yeah, stop sharing.
Oh, is that sharing back again? Yeah.
Yeah.
Okay,
Yes.
sorry about that. So basically, to calculate the perimeter, we just add all sides. Oops, I've got someone trying to join. Let me find out who's trying to join in. I think she had dropped because she was in before. Okay, yeah. So basically, what you do is you do 6x plus 6x plus 2x plus 2x. So then that becomes
16x.
Yeah, 12 plus 4, 16x. So answer to question 1 is 16x, yeah? Let's call it P. Whereas the area, it's length times breadth, which is 6x times 2x, that is 12, yeah, x times x, you can rewrite it as 12x squared. Okay? Now, it just means if you're asked, the next question could be, what happened if x equal 2? Then you just substitute 2 in there. So you become 6 times 2, 12 meter by 12 meter, 4 meter by 4 meter, which is 32 meter. Okay. Okay, so the next question we had was expand out the brackets. So 4y times x, 4xy, yeah? And then I've got 4y times a negative y, or minus, so that becomes negative because it's negative. So 4y squared.
Yeah.
This is how you would just expand the brackets. Okay. So that's basically what they were asking us to do. Have you noticed that as well? I wrote x before y, because mathematicians are a bit OCD sometimes, and they like to put everything in order. So the letters, they put them in the correct order to make it easier for them to remember. Okay. So the next question is find all the missing angles. So here I've just put you what you need to look for when you're looking for angles. So properties. So we've got what we call corresponding angles. Whenever you can see a letter F appearing somewhere, you can have opposite angles, which are the same. If you can see an X shape, and if you get the Z, you've got alternate angles. In each of those corners, you'll have the same angles. So that means if I'm looking for all the angles here, or the other one that is quite important is on a straight line, the angle is 180. So I've got a straight line here. If I've got 100 here, what would be, yeah, so you get 80 on this side. So maybe if we do the easiest one, which is the straight line, I've got 80 here. Now, because I've got 100 here, and I can see an X shape here, the opposite to the 100 would be another 100. Yeah. So we've got another angle. And the same here, I've got 80 there and another 80 there.
360, that's sometimes.
Yeah. So now you see that F here, you can put it in any position you want. That F could be as well, that F there. So in there we had 100. So the corresponding angle to that 100 is just below it. It's the same angle there because we've got that F shape there. So if this is 100, that's got to be 100 as well. Okay. And if this is 100, because we've got a straight line, that's got to be 80. Yeah? So, you see that was an F, but you've got another F as well here.
Yeah.
Going from there to there. So if this is 60, it's got to be 60.
60. Which means the one in between the two 60s is at 120.
So between this one and this one, yeah, so you've got 120 here because all angles in a quadrilateral adds up to 360. Or you've done a straight line that is 120, yeah?
Yeah.
Yeah. So I thought you were gonna outsmart me and tell me that all angle in a quadrilateral, they would add up to 360.
I didn't want to outsmart you.
So basically, if you got a rectangle, you've got 90, you can quickly see that 4 times 90 is 360. But yeah, no, that's good that you saw the straight line there. So now we've got all angle in a quadrilateral adding up to 360. There is one missing angle here. I've got 60, 80. This triangle. Yeah, so all angle in a triangle add up to
180.
180, yeah. So because we've got 80, we've got 60, to get to 100, you've got 40. And that's us, we've got all our angles. So this basically shape can touch all the different angle properties that you would need one day when we're gonna get to angles in a circle or angles based on shapes. Because we've done angles in a triangle, adding up to 180. So I'm gonna put sums 180. We've done the straight line, and we've done angle in a quadrilateral, adding up to 360. So this is a common exercise that is given to people who wants to revise all their different angle properties. Okay. And we've got them all explained here. So I always look for F, X, Z, a straight line, a triangle, or a quadrilateral. And they were all in this shape here. Okay. So, reminder of the balancing method. whenever we've got x minus 5 equal 11, what do we need to do to get rid of the take away 5?
Add 5.
So we add 5. So adding 5 on each side will get rid of the 5 there, and you end up with x equals 16. If it's an add, we take it away on both sides. And because we are using what we call the balancing method, what we do on one side of the equation, we need to do the same on the other side, and x equals 29. Okay. Now, adding, subtracting was one thing. If you got to time, we did say that the opposite of time, the opposite of multiplying is dividing. So 6 divided by 6 will give me a 1. 72 divided by 6 will give me 12. Okay. You just say to yourself, 672 is 60 plus 12. So 60.
Eliminating the x and the 2 in front of the x to give you a single term. Yeah, so you just eliminate it. Is that correct?
To get rid, I mean, yeah, I tried to get rid of the 6. Is that what you're asking?
Yeah, just eliminate it by.
Yeah, by eliminating it by, yeah, 6 divided by 6 becomes 1, remember? 1x is just written in math as x. Okay, whereas on the other side, you've got 72 divided by 6, which is 12. On the example on the right, we've got to divide by 2 to get rid of that 2. We'll do it on both sides. And this time we've got 11 over 2, or if you want, you can write it as 5.5. But you can leave it as 11 over 2 or 5.5. There's 3 ways to write this answer. Okay, so that's what we call balancing method. Now, at level 2, we make it a bit harder. We put a number on the other side, but we use the same method. First of all, we get rid of the negative 2 by adding 2. Then that means we end up with 4x equals 36, and then we divide by 4 each side, and 36 divided by 4 is 9. So the one thing I ask all my students to do whenever they give an answer is to check that the answer makes sense. You just substitute that 9 into x. 4 times 9 is 36. 36 take away 2 is 34. Then you can say that for sure this is correct. On the other side, we take away 9, both sides. You end up with 2x equals 22. You divide by 2 both sides, and then x equals 11. 2 times 11 is 22. 22 plus 9 is 31. I know that this is my correct answer. This is what we call harder equations, because now we're going to make it a bit more complicated by putting x's on the left side and x's as well on the right side. So how do we solve that? Again, we use the balancing method. We try to make all the x's on one side and the numbers on the other side. So the first thing is come up with a method. So I've just told you we're going to use the balancing method. So first thing first, I'm going to take away 2 on each side. So some people decide I would rather take away x on both sides, but you end up with the same answer. So by taking away 2, you get 3x equal x plus 8. Now this is a plus x I want to get rid of. How do I get rid of the plus x? I take it away. But if I take it away on that side, I take it away on that side too, and then you end up with a much easier equation to solve. 2x equal 8. You divide by 2 both sides, then x equal 4. Okay, and that's us. We've solved that. And if we had started with taking away x on each side, rather than dealing with the 2, we would have ended up with the same thing, but just you'll get 2x plus 2 equal 10, then you take away the 2, and then 2x equal 8. Okay, so now try the same method on the right hand side and let me know what you get with x at the end. Okay, so the way to go through it is using that same kind of method. First thing first, we're going to add 5 on each side to get rid of the -5 on the left-hand side. That means we end up with 4x equal 2x minus 20, because minus 25 plus 5 is minus 20. Then I'm going to take away 2x on both sides, and I end up with 2x equal negative 20. And my last step is to just divide by 2 both sides, which is x equal negative 10. Okay, and I can quickly check that this makes sense. 4 times negative 10 is negative 40. Negative 40 minus 5 is negative 45. 2 times negative 10 is negative 20. Negative 20 minus 25 is negative 45. Now, harder equation, but this is just to practice. So just like we did earlier on, I'm going to get rid of the 4 first by taking it away. Okay, so 2 ways to deal with this. Have you noticed that the 3x, the bigger of the 2 is on the right side here? So you can rewrite this as 3x minus 10 equal x plus 4 to make it easier for you. Because a equal b is the same as b equal a. And now you can say, okay, I'm going to have all my positive on my left side, my negative. If I move x on that side, 3x minus x will still yield me a positive number. Okay, so that's a way to do this if you want to. So add 10, 3x equal x plus 14. Take away x on each side, 2x equal 14. So you're dealing with a positive here, which makes it much easier for you. Divide by 2, x equals 7. 7 plus 4 is 11. 21 minus 10 is 11. So I know that this is correct. Again, I've got 7x on the right. I'm going to swap them around to make it easier for me. 7x plus 11 equals 4x minus 1. Take away 11 both sides. So minus 11 minus 1 to make it more negative. So 7x equals 4x minus 12. Then you take away 4x on each side. You end up with 3x equal negative 12. Divide by 3. X equal negative 12 divided by 3, which is negative 4. I'm going to check that as well. 4 times negative 4 is negative 16. Negative 16 minus 1, negative 17. 7 times negative 4, negative 28. Negative 28 plus 11, negative 17. So I know that these are equal. So it's a smart way of making sure that you will divide by positive numbers by always making sure that your bigger of the two x's is on the left hand side, for example. Okay. So I didn't put any of those to apply. We're not going to go through this. Yeah, maybe. Yeah, what we can do is, don't worry about question 1. So ignore question 1. We're going to take a quick break. And what you could do is you could just, when we come back, we'll look at the question 2 and question 3. Okay? Before we move to the next section. So let's have a look at the next set of lessons. So equations with brackets. Equations with brackets. So we're going to solve the equation with brackets, and remember the rule for multiplying out brackets, and then we're going to apply the balancing method. So first example I've got is just, we need to get rid of the brackets before we can solve the equation. Basically, that's what it is. So in a NAT5 type of question, you will get something similar to that. You will get marks to get rid of the brackets first, which is multiplying out 3 times x, 3x, 3 times -2, -6 equals 33. Then we're going to get rid of the -6 by adding it on both sides. 3x equals 39. Now you can see that 39 is a multiple of 3, because remember what we said, to find a multiple of 3, you just add the 2 digits. So 9 add on 3 is 12. 12 is in the 3 time table. That means I'm going to have a whole number, x equals 13. Okay, so that's basically the idea of removing the brackets before you solve the equation. So you've got a couple of examples here. We're going to do the first one together, and then the other one you'll try it yourself. So again, 4 times x, 4x, 4 times -3, -12. Then I just put the plus 9 equal 25. So the first thing I'm going to do -12 plus 9, that's -3. And now I'm going to add my 3 on both sides, 28. And then divide by 4 both sides. And 28 divided by 4 is 7. Quick check before we go. 7 minus 3, that's 4. 4 times 4, 16. 16 plus 9, 25. This is correct. So now try the one on the right. Okay, and let me know how you got on. So exercise 13A, 3, 4, 5, and 6, and it's page 113.
Thanks.
Okay, so let's have a look. So the first one is a bit like what we've just been doing now. So you're going to be solving the followings. So maybe we can do one that is, one in the middle together. Okay, so this should tell me that I'm going to do it on the blue side here, white here. So E, basically for E, I've got 20 minus, so this is like a -1. It's an invisible one that I do. -1 times 1 is just -1. -1 time minus x, that becomes plus x. And minus 2 times 2, that's minus 4. And minus 2 times a negative 3x, that becomes plus 6x. Yeah? And all this, they've asked us to make it equal to 1. Now we're going to tidy this up. I've got 20 minus 1 minus 4, so 20 minus 5, which is 15. Yeah? So 15 and 6x plus x, that's 7x. So 7x plus 15 equal 1. Yeah. So looking at this, I've got an idea what x is, because the only way I'm going to get 1 here if I take away 14 from 15. So that means this 7x should be equal to negative 14 for this to work. So let's try that. If you take away 15 from each side, if we apply the balancing method, right, then you will get 7x equal minus 14, which is what we just said there. Just to show that the balancing method is good to use. And now, to balance it all, you just divide by 7, both sides, and that would mean that x equal negative 2. So we solved the first one. There's quite a few lines of working. That's the only way you can get through. So I'm going to quickly check it. 2 minus 1, that's 1. 20 minus 1 is 19. 2 minus 3, sorry, what did I say? 2 minus 1? No. So 1 minus minus 2, which is 1 plus 2, which is 3. So 20 minus 3 at the top. So you would use a 20 minus 3 minus 2 times 2 plus 6. That's 8. So 20 minus 3 minus 16. And that is 20 minus 19. And that is 1. Yeah, so use a pen and paper, and you can quickly check that our answer is correct. And you'll be able to do the other ones, A, B, C, D, and F, G, H. It's just practice. Most of the time on these. Okay. The next exercise, so we said exercise 3, 4, 5, and 6. So 4, very much the same. So the first one didn't have a star, so this is same type of exercise, basically. You may need to swap it around so that you get your bigger of the two numbers on the left-hand side, but very much expanding out, getting rid of the brackets, simplifying it, and then solving it. Let's see exercise 5. 2 rectangle of the dimension shown there. The area of the red is greater than the area of the blue. The difference in the areas is 131. Determine the area of the red rectangle. So, first of all, we need to determine the area of each of them, because they've told us that the difference between the areas is 131. So the first thing you would need to do is to do area of this one. Yeah. So we've noticed earlier on, length times breadth. The first one is 2 times 3x minus 4. That's the area of the first one. Yeah. The area of the other one is 19 times x plus 1. Yeah. So we've got A1 and A2. Now, this is important. They've told us that the red rectangle is greater. So I've got A1, I've got A2. Because the red rectangle is greater and the difference between the bigger one versus the smaller one is 131, the next stage is to write that A2 minus A1 is equal to 131. So that's basically what you've got to solve. So you need to write 19 times x plus 1 minus 2 times 3x minus 4 equal 131. So you've got to solve this equation to find x. Once you find x, they've asked us to determine the area of the red rectangle. You replace x with its value. Once we find the x, if x is 3, for example, 3 plus 1 is 4. 4 times 19 is going to be the area of the red rectangle, or A2. Okay, and you give your answer in centimeters square. Okay, so you could see there was a little bit of cognitive, thinking to do here, because it was easy to just say, oh, this take away this is 131. We wouldn't have got the right answer, because you needed to do the bigger one, take away the smaller one as a positive value. Because if it's the smaller one, take away the bigger one, then you would get a negative value. Okay? So the next exercise, I've got Sinead's and Kyle's teacher give them both the same number. Kyle multiplies the number by 6 and then subtracts 4. So basically, yeah, let's call that number x. So we're looking for x, a number. So if it's 6x, take away 4 is for the first one, whereas adds 3 to the number and then multiply by 4. So 4 times x plus 3. So this is the bit where you need the brackets. You add 3 to the number and you multiply by 4, you get this. Form an equation and use it to find which number Karen and Sinead were given by their teacher. So they got the same answer. Yeah, so basically that number equal that. That's what you've got to solve. And then find x. So this was A, and B is just to find x. Okay? And once you find x, you'll know the number that you're looking for. So that's how you use algebra to solve these kind of, is that a riddle or a question? Okay. And that means you can go to a pub quiz and then use a paper and quickly give the answer.
What's that called?
I know, something like existed a long time ago, yeah.
We used to go to pubs. Used to have less grey hairs then. Jeez.
Yeah.
Scary.
Okay, so that was question 6. The next set of lesson, what time is it just now? 7, quarter past 7, yeah, so
10 o'clock, I think it's 10 o'clock, we
better pack up. Wow. Yeah, so we take a wee break, because now we're going to look at equations that comes quite often in Nat 5. Obviously, remember what I said at the start. A lot of these are revisions from level 4, but once you're going to start tapping into equations, then that's going to be more your level 5, Nat 5 type level. Okay,
Mhm.
but it's always good to be able to solve equations, and we look
Yeah.
at simultaneous equations as well. So if you want to grab a coffee,
Nice.
then I'll be back in 5 minutes again. Okay.